Stretching the graph of f of x equals sine x vertically away from the x-axis is given by g of x equals a times sine x, provided that a is greater than 1. Sine x stretches away from the x-axis by a factor of a. Consider f of x equals sine x, here in red, and one of its transformations, in blue, g of x equals 2 sine x. The graph g of x is the result when f of x stretches away by a factor of 2. Shrinking the graph of cosine x vertically towards the x-axis is given by h of x equals a times cosine x, provided that a is between 0 and 1. Cosine x shrinks toward the x-axis by a factor of a. Consider f of x equals cosine x, here in red, and one of its transformations, h of x equals 0.5 cosine x, here in green. The graph h of x is the result when cosine x shrinks toward the x-axis by a factor of 0.5. Let f of x equal sine x. Its graph is displayed. The functions g and h are given by g of x equals 3 times sine x and h of x equals 0.25 times sine x. A. Carefully sketch the graph of g of x on the grid below, label a maximum point on the graph of g, and B. Carefully sketch the graph of h of x on the grid below, label a maximum point on the graph of h. Alright, so let's have g of x equal 3 times sine x being green. What we're going to do is take each point on this graph and multiply the y value by 3. So here at the origin, the y value is 0. 0 times 3 is still 0, so this point will remain where it is. However, this point has a y value of 1. So now 1 times 3 is 3, so this point goes all the way up there. Here we have a y value of 0, so that's going to remain where it is. 0 times 3 is 0. Here, negative 1. Negative 1 times 3 is negative 3. So this point moves all the way down there. And we can just go through and fill in all the points. So this graph, g of x, looks something like this. I'm not very good at drawing, but this will have to do for now. All right. And this one. Alright, so here is g of x. Next, in blue, let's do h of x equals 0.25 sine x. So, at each point, we multiply the y value that we get times 0.25. So it's 0, it's also 0, because 0 times 0.25 is 0. At this point, we have a y value of 1. 1 times 0.25 is 0.25, so this point moves all the way down to there. And then the 0 remains. Here we have negative 1 times 0.25 is negative 0.25, so it's like there. Alright, so this graph looks something like this. Alright, there we go. And here are much nicer drawings of g and h. A maximum point on g is now pi over 2 comma 3. And a maximum point for h is pi over 2, comma 0.25. Let's consider the function given by f of x equals a times sine x plus k. The midline, y equals k, here in blue, is the horizontal line that is midway between the high and low points. The amplitude a of a sinusoidal wave is half the wave height. This makes the wave height equal to 2a. So from here to here is a. So the total height from here to here is 2a. The maximum value of a sine or cosine function is k plus a. So this point here is k plus a. The minimum value of a sine or cosine function is k minus a. The graphs of the functions sine x and cosine x complete one cycle on the interval where x is greater than or equal to 0 and less than or equal to 2 pi. Of course, starting a cycle at x equals 0 and ending at x equals 2 pi is arbitrary. Slide the rectangles left and right. One cycle of the sine wave is enclosed by each of the dashed rectangles. Discuss the following. What are the left and right boundaries of the dashed rectangles? Compare and contrast the sections of the curve in each rectangle. So we can move it there, or there, or there. The period of sine x and cosine x is 2 pi. In the figure below, the period is one cycle and is enclosed by each of the dashed rectangles. Are the blue and green curves congruent? Discuss. The curve sin x for x belonging to the interval L to L plus 2 pi is congruent to the curve sin x for x belonging to the interval L plus 2 pi to L plus 4 pi for all real numbers L. A period of sin x and cosine x is any multiple of 2 pi. The functions sin x and cosine x repeat every 2 pi k for integer values of k. This means sin x equals sin of x plus 2 pi k, and cosine x equals cosine of x plus 2 pi k. The period of sin x and cosine x is 2 pi. The period is the smallest period and represents one cycle. True or false? Sin 1 equals sin of 1 plus 2 pi. This is true. Sin 1, so that would be like putting 1 in here, equals sin of 1 plus 2 pi, and k in this case is 1. So plus 2 pi. This is true. Here, however, we have 21 pi. This is not a multiple of 2 pi. This is an odd number, 21. So this is false. 9 pi is also an odd number. So this is false. We can't divide this evenly by 2 pi. However, 80 pi, this is an even number. We can divide this by 2 pi. The k value here would be 40. So it's like 2 pi times 40 gives us this 80 pi. So this one is also true. True, false, false, and true.